Quantum mechanic model of the atom. Here's a picture of what today's model looks like. Section 13.1, subsection 2. Previous models of the atom. Previous models have been physical models based on motion of large objects, such as the planets. The quantum model is primarily a mathematical model. 1926, Erwin Schrödinger, he used the new quantum theory. For electrons to move to different energy levels requires a quantum of energy. Quantum is a small packet of energy. To write and solve a mathematical equation, this equation describes the location and energy of an electron in a hydrogen atom. Modern model is called the quantum mechanic model. Comes from the mathematical solution to Schrödinger's equation. Similar to Bohr's model, like Bohr's model, the quantum model restricts the energy of electrons to certain values. Different from Bohr's model, however, the quantum model does not define the exact traveled path of the electron. Bohr's model is more like the solar system, where each electron travels in concentric circles around the nucleus. In this case, it's different in that it doesn't necessarily follow that same path. Example, it estimates the probability of finding an electron. That's what Schrödinger's equation talks about in the quantum mechanic model. Probability plays a big part in the quantum mechanic model. Example, probability, if you place 3 red marbles and 1 green marble into a box and then pick up 1 marble, the probability of picking up a green one is 1 in 4, or 25% probability. The space around the nucleus is assumed to be a cloud. The higher the probability of finding an electron will be greater in the thicker parts of the cloud as opposed to the lighter parts of the cloud. So here is dark part of the cloud, high probability of finding an electron. As we get to the less dark or the lightly shaded, then we have less of a chance of finding an electron. In this picture here, the darker areas are where we're going to find more electrons, the lighter areas where we're not going to find too many electrons. All relates to probability. Or more dense the cloud.